Today we're going to be looking at learning target 7D, which is graphing piecewise functions. A piecewise function is often defined as many functions subdivided over a defined domain. It may include one or two functions over that given period, or could possibly contain more depending on the need. This idea of piecewise functions is not entirely new to you, as earlier in the year you create a graph of distance from the door as time goes by with Mr. Dunn and myself running across the room. Here are some examples of other piecewise functions. A couple things to note that we're going to talk about on the next page is this idea of open circles, as I'm circling here in green, and closed circles, which I'm circling in blue. Now, the concept itself of open circle and closed circle is not a new concept. It's something that we used when we were graphing inequalities on a number line. But it is important to note that it's our first time using it as it pertains to graphs. So an open circle still means that data is not included as part of that function, and a closed circle means that data is included as part of that function. One thing to note, if there are no circles included on the graph, it's assumed that the graph does not contain any breaks. So if I look back at the examples, notice the bottom two graphs don't have any dots. That's because each line bumps up next to each other. So if that happens, you don't have to include dots, and oftentimes you will not see them. So let's look at what the notation and the graph of a piecewise function would look like. The first thing that I look at is the inequality piece at the end, because that's going to give me some key pieces of data. So here where it says if x is less than or equal to 4 and x is greater than 4, that creates a divide for us. So what I'm going to do is I'm just going to draw a dashed line here where x is 4, because our function will look like something to the left of that and then something different to the right. And for the sake of this graph, I'm going to put the top part of it in green and the bottom part in blue, just so that it's easy to recognize each of the two functions. So for the top graph, I've got negative 2x plus 8, so my y-intercept is 8. Put a dot there. And I'm going down 2 over 1. Now it's important to note that since it's less than or equal to, at negative 4, or pardon me, at positive 4, that will be a closed circle. So when I graph this line, it will go like this, and it would continue forever in the negative direction, since all that is less than or equal to 4. For the next piece, I've got 1/2 x minus 2. So I'm going to put small dots here at my y-intercept, and my slope is up 1 over 2, up 1 over 2. Notice how these are going to match up at that point. Now when I actually draw my line though, it's only for those spots greater than 4. So I'm going to start here, and then it will go forever in the positive direction. If I want to, I could go ahead and erase the previous dots, just so that it looks a little cleaner. And oftentimes you won't see this dashed line, but for the sake of this, we'll leave it on there. Let's go ahead and look at another example. With this example, I've got two areas that are important. I've got where x is less than 1, so I'm going to go ahead and put a dashed line at 1. And I've got where x is greater than or equal to 4. So I'll put a dashed line there. And I've also got this area between those two dashed lines. So it's kind of broken into 3 pieces. So again, just like last time, I'm going to let my first piece be green, my second piece be blue, and I'll put my third piece in red. So for x plus 4, I've got a y-intercept of 4. And it's going up 1 over 1. So I'm just going to plot these points just to help me. It has less than 1, which means that here it's going to be an open circle. And we're looking at all the points to the left. For that in-between piece, we know that g of x is equal to 2. And that's greater than or equal to 1. So I'll have a closed circle here. But less than 4, so an open circle here. And all the points in between. And then it's going to be the square root of x when x is greater than or equal to 4. So one thing that I can do here is I could actually use my graphing calculator, and you could do this for any piece. But I just wanted to show you specifically for this. And there we go. So we get the square root of x. So second square root of x. And I want to look at my table for when x is greater than 4. So at 4, I have the point of 2. So at 4, 2. So this one will actually meet up, and I'll have a closed circle, which is red. My next whole number pair is at 9, 3. And remember, my square root function is curved. But what I'm missing here, just to show you, are these pieces that make up the first part of the curve. So when I draw this, it would look like that. So here you can see all 3 pieces of this piecewise function. The next piece that we're going to look at is actually going the other way. So here I'm giving you a graph, and I'm asking you to write out the pieces in form. So it doesn't matter what you use as your function notation, f of x, g of x, h of x. You can pick any letter. For me, I'm going to use b of x for braid check. And I see that there are 3 pieces. I've got a piece that's less than or equal to -3, and I can tell that because of the closed circle, and that's going less than. So I have part of it is if x is less than or equal to 3. I have a part, -3. I have a part between -3 and 0. And when I look at that, they're both open circles, which means that if x is between -3 and 0, but does not include either side because of the open circle piece. And I also have when x is greater than or equal to 0. And I know that because of the closed circle. Now it's just coming up with the equations for each piece. So my first part, it's staying constant at -2. So I know that my b of x there should be an equal sign here, sorry about that. My b of x will equal -2 when x is less than or equal to -3. My equation for the middle piece, my slope is down 1 over 1. So I know it's going to be -1x, or -x. And my y-intercept is at 4, so +4, when it's between -3 and 0. Then for my last piece, my slope is up 1 over 1, so it'll be a positive x. My y-intercept is at 0, so I could just leave it as x. It would be +0 if you want to put it, or I could just leave it as x. And that's how you would write your function given a graph. Here are some practice problems that you could look at. So for the top two, go ahead and create a graph. For the bottom one, go ahead and create the function. Go ahead and pause the video as the next slide will have all the solutions. For the solutions, I put the first part of the graph in green, the second part of the graph in blue, and the third part of the graph in red. So when you look at the solutions here, that is what your solutions would look like. Make sure you come with any questions you may have for Mr. Dunn, myself, or Ms. Knutson.